Now let's look at 2024 F equals MA problem 23. So this problem talks about an inelastic collision, right? So it says that if we have the ping pong ball and a paddle. So what's the ball? Initially have the height h, and it collide with the paddle and bounce it back, so they can just reach the height h/2. So what it tells us? It tells us the following thing, because we know that h is proportional to v squared, where v is the speed when the ball is ready to collide with the paddle, right? So after the collision, so we can only just reach the half of the height. It entails that after the collision, the velocity is reduced to v over square root of 2. So which means that, so right before it hits the paddle, suppose the speed is v, then immediately after the collision, the speed is reduced to v divided by square root of 2. So this is what this problem tries to tell us. Okay, all right. So the problem tells us the following scenario, right? Because we don't want to lose the speed after the ball collides with the paddle. So once the ball tries to collide with the paddle, and now we'll move the paddle up to give it some upward speed. So let me call the speed that the ping pong ball will collide with the paddle before the collision s. So let me call it w. Okay, and at that moment, so let's say we give the paddle an upward speed called v. Okay, so by creating such a relative move, the problem says that, so after the collision, the ping pong ball could go back to the same height, which means that after the collision, it will gain an upward velocity the same magnitude as w, right? How that can be achieved? Okay, so now we have to change our frame from the ground frame to the paddles frame. Okay, because the paddles frame, we know that before and after the collision, so the speed actually has this change, is divided by square root of 2. Okay, so let's do the analysis in the paddles frame. So originally in the ground frame, we have the downward velocity is w, and we look at this velocity from the paddles frame. So if the paddle is static, it means that the ping pong's velocity becomes w plus v. And in the same frame, after the collision, it becomes w plus v divided by square root of 2. Okay, so this is the speed in the paddles frame. And now we need to convert it back to the ground frame. So we get this one plus v. Okay, so basically this is the entire process about what happens before and after the collision. And the problem says that after the collision, we still want the speed to remain the same. There's no loss, right? So we need to equate these two yellow terms. So this allows us to establish one equation. And for this particular problem, recall that v is just equal to 1. So by solving this yellow equation, we get w is equal to 3 plus 2 square root of 2. And this problem finally asks us to compute the height we can reach. So the height can be calculated by simply using the formula w squared divided by 2g. By doing some algebra, you'll see it is equal to 1.7. So the answer is D.